We will now demonstrate the phenomenon of resonance. Now I have here just a black ABS pipe used for plumbing. It's 1.5 inches, and a tuning fork. And what I've got here is just a pop bottle with the top cut off so that I can use that as a water container with then the pipe standing in there. I'll vibrate my tuning fork and hold it over the opening. And as I raise the pipe, the sound reaches a maximum at this height. Let's try that once again. Different frequencies of sounds require different lengths of pipe in order to achieve resonance. And that's, of course, the principle of a pipe organ. The low sounds, the sounds with a low pitch or low frequency, have the very long pipes, whereas the high frequency sounds have the shorter pipes. And so if I want to get some resonance with my 512 vibrations per second, I need to use a shorter column. So let's try that. And here's our resonance. We can also set up resonance in juice bottles. I have 3 different juice bottles here, each with a different level of water. I'll again take my 256 cycle per second and here we're getting resonance, but not with the other 2. So in order to observe the resonance, we have to have just the right amount of airspace in the bottle. This gives us resonance. And again, that varies for the different frequencies. If I use a 512, very intense here. I'm going to demonstrate the principle of resonance that occurs in an air column using a golf ball to which I've glued a string using hot melt glue. And to make it stick better, I've actually scraped off the surface of the golf ball a little bit and then held that in a clamp. We'll put it still, and then I take a piece of tubing and blow against the golf ball, and I'll do that so that I blow every time it swings towards the end here so that I give it a little bit of energy. You can see that when I puff at the appropriate time, I transfer some of the energy from the blowing air to the swinging golf ball and cause it to swing a little bit further. This is, of course, also what we do when we swing a child on a swing. We give the child a little push just when the child reaches the far end of the swing. And we give it a little bit, we give the swing a little bit more energy, and that then causes the swing to go up higher and higher. If we do that at the wrong time, we say it's out of phase, and the ball then stops swinging. So in order to transfer the energy, it has to be just the right frequency. And that's the situation with our water bottle or air column as well. In order to get the resonance, we need just the right length so that the vibrations coming from the tuning fork will intensify in the air column here, giving us then a louder sound.